Hey everyone, this is Mayu. Welcome back to ML Works. In this video, we'll be discussing or playing with text and image embeddings for retrieval. So what we'll do is we'll have a model which is jointly trained on image encoder and as well text encoder, and we'll use those encoders to generate our embeddings. And once that is done, we'll use a data set and turn that data set has into what embeddings, and then we'll pass in a user query and do similarity search and fetch those particular relevant documents or relevant images specific to that particular user query. Now with that, what we'll do is first we'll start with the installation for this particular exercise. Okay, first what we need is we need the data set, and this is Fias GPU will be helping us to create the index for the embeddings. So we'll need that. Then we have transformers library which will have the model for us, and sentence piece for tokenization. So let me just run this cell. So it's connected to Google Colab and it is using T4 Tesla GPU. Now I have already installed these packages, and since it's got restarted, let's see. Yeah, so it is already installed. And next step is to import the packages which are required. And since we are using GPU, okay, so first we import the packages here, like the torch image for image pre-processing, and then viewing images and the transformer models, transformer based transformer library which contains text pre-processing with the auto tokenizer, then image pre-processing with auto image processor, and then auto model for loading a model from the Hugging Face hub. And then we are doing something called as we are importing the packages Face and NumPy, and here we are mentioning the device. If your system is capable of having the GPU, then it will utilize the CUDA, otherwise it will take or run everything in CPU. Now here comes the next step, the model what we are going to use, which is OpenAI's Clip VIT base patch 16, and we are running it on a specific device based on the previous step. This is the model and its corresponding image preprocessor. Now this model is quite unique. This was the first model which allowed us to jointly train image encoder and text encoder. So that's why we have this. We are using this particular model where we fetch in this particular model's image processor, and again here the same model's encoder in a sense. So we load image pre-processing, text pre-processing, and then the exact model that is required. So let us run this. So this will, it's already there. So it is already available. Could not find image processor in the image processor config loading. Let me check here if I go and type in processor. Let's see. So it has loaded it actually. So next step is we have imported the packages, installed, imported, and now we have to download the data set on which you want to create your embeddings. So we are downloading a data set called as New York Caption Contest. You will have images and its corresponding description. Okay. So we'll download that data set and it's already downloaded, I am assuming. So let's run this again. Yeah, so it's already there, and this is the first image, DS train 0 image and its corresponding description. DS train 0 image description. So these are two women looking out at a window. There is a snow outside, there is a snowman with human arms. So this is a caption for this image. Now what we'll do is we'll generate embeddings. Let me just open this cell. So here if we see, this is our train data set and DS train, okay, that is passed to data set and dataset dot map. So what we are doing is we are mapping a function to this particular train train data set, okay, and we are applying this function on specific columns called as image description. Okay, image description is nothing but a text, and here we are also getting model dot get text features using tokenizer, the tokenizer which we got it earlier here. So we are applying the tokenizer and then applying it on the image description, and there are also some hyperparameter tuning or hyperparameters are being added here, like truncation is equal to true and we have to return the tensor in PT format. Okay, those details are passed here and we are running it on a GPU, and all this will be creating a column called as embeddings. Okay, So currently, if you go and see this DAs, so let us check if it shows. Okay, so here if we see, we don't have embeddings here anywhere. We have image, image description, image location, other entities, questions, caption choices, all those details we have, but we don't have embeddings. So once you run this particular specific cell DS with embeddings, you will generate a column called as embeddings, which will be the embeddings of all the image descriptions you have. Okay, let me run this. Okay, it's already executed. Let me run it again. It took 44 seconds. That's why I'm not rerunning things. So this took 4 seconds now because since it has already been executed. Now if you see DS with embeddings, you will see embeddings column. So let me run it again. Now these embeddings are present. Now we have to attach an index to this embedding such that it will be helpful for us to retrieve some specific embeddings based on the index. So what we do is we do something called as indexing. DS with embeddings dot add fast index to the particular column. For the embeddings, we are adding a specific index. So let me run that. So it has been done. So we have assigned an index as well. Okay. Now what we'll do is, this is for text. So this is for image description. We are passing the tokenizer image text tokenizer, applying it on image description. Now we can do the same you for images itself. So what we'll do is we'll generate the image embeddings for images. We have example of images and then processor, which is image processor, and the model get image features. And again the same thing, it will run on CUDA, then it will deattach, and then we'll move it to CPU and turn it into NumPy array and pass it to this particular column, image embeddings column. Now let me run this. And again, as done for text embeddings, we added an index. Similarly, we'll add an index for image embeddings as well. So one thing to notice, right, what I have noticed with this particular exercise is if I go directly, okay, since I have added an index for both image embeddings and embeddings, okay, it should be able to fetch the particular relevant embeddings when I pass a query. For example, if I pass a prompt of a snowy day, okay, it will be generating an embedding here, and that embedding will be it will be generating an embedding corresponding to this text. And this embedding, if I go on search, okay, it should give a result. Okay, it will give an one result only. But what we notice is it is showing again index with index name, embeddings not initialized yet. Please make sure you call add fast index. So that's why what we do is we again apply an add fast index. Okay, and then we try to fetch the relevant index based on this particular prompt. So if I just run this again, you will see it got executed, and now we have something called scores, and we have retrieved examples. This is the retrieved example and the corresponding image description based on this particular prompt. So the score is 38.35, and the image description we got is a man is in the snow. Based on this prompt, this is the relevant text that we got. Okay. Now what we can do is use the same corresponding to this image description. There is also an image. So we can fetch that as well. So before we do that, there is something called as we are downscaling the images. Okay. To view the images here. So what we do is just a pre-processing function you can think of. Okay. Downscaling of images. Now what we do is we retrieved example image description is present. Based on the image description, we also fetch the images. So this is the image we got corresponding to the prompt a snowy day, and its corresponding text is this one, and its corresponding image is this one. Okay, so this is till now what we have seen is we pass a prompt, text prompt, we get corresponding text embedding and corresponding text, and then followed by based on that correct corresponding text embedding, we are getting the image embedding as well, which is directly mapped to a particular image, which we can see here. Now this is for images. Now if you want to do for an image, okay, if you want to pass an image and then you find the similar images that is available in the data set, what you can do is you download an image, okay, then do some kind of pre-processing as done here, downscale the images, okay, and then corresponding embeddings can be generated. Okay, we pass this image again to an image processor, and it will generate an image embedding. that image embedding is passed to a there's a JS with embeddings and get and compare it against the image embeddings, okay, which we generated earlier. So this images embeddings will be compared against the image embeddings and get the top one result. So it got executed. We got the score, retrieve example, and retrieved example we are again getting and fetching and showing it in the this particular cell. So this was a specific image of beaver, and the retrieve example is showing up for bear. Okay, bear and the salmon fish upstream, but they are grizzly bear and are in shock. The bear has a smug look on his face when he sees the salmon. Okay, so this is the corresponding similar image which we got for this particular embedding. So we have tried to pass in an input image, turn that into embedding, and then we compared against the existing image embeddings and fetch the top one result. Okay. Now this is done with the task with respect to what embedding and similarity search. Now what you can do is once we have our embeddings and we have added an index to that embeddings, we can store that particular embedding. Okay. So these are the two commands that you can use for embeddings, saving the embeddings and its corresponding indexes. So once that is done, we are done with the task of embedding, multiplying with the embedding for similarity search. Okay. Now the next thing what we can do is we can store our results in Hugging Face repository. For that you can do a bunch of things. This is an optional thing which if you want to do or if you want to learn, you can learn. So this is like you connect to the Hugging Face hub. You pass in the token here and then it will be connected to your account, Hugging Face account, and then you can create your own repository here. If it is a data set, you pass in the data set and then you upload the data set what is required. And if you want to snapshot don't download, this is repo data set local directory, and if you want to download from a particular repository, then you can give this particular command, it will download that as well. So, and again, this is again for what after you download, how you want to do processing and again do the inference that can be done with these commands. Okay, these are optional. If you want to try it out, you can do this as well. With that, I'll conclude this video. Thank you so much.